like that. What are the coefficients of the balanced reaction? So the first thing you need to do is balance. Once again, I made this very easy because all the questions were based on this. You're something a little bit tougher, obviously. What's the answer going to be here? So we put a 2 out in front of here to balance the oxygen. Then you need a 2 here to get the nitrogen balanced. If you have trouble with this one, you got some work to do. And this is super easy. You need to practice a little bit more with balancing if this is problematic. So that's our coefficients, 2, 1, 2. With unlimited nitrogen, how many moles of N2O are produced from 3 moles of O2? This is like a quiz question. Did I ask something like this on the quiz or something? 6, right? Which is E. Why? Right, because it's just multiplying by 3. That's it. We're taking 3 here. So we're multiplying this by 3. Then this has to be multiplied by 3 to give you 6. It's just a ratio recipe, right? I just scaled it up and said, okay, I want to use 3 times as much oxygen, and I got unlimited N2. How much N2O am I going to get? I'll get 3 times as much, 6. You good? All right. With unlimited N2, how many grams of N2O are produced from 3 grams of oxygen? Well, what are we going to do? We've got 3 grams of oxygen. What's that? Right. Mass to moles, mass of A to moles of A, moles of A to moles of B. What we're doing here. .0 grams of O2 times, this is O2, so we'll say 32 grams per 1 mole. And then times we need to balance stoichiometry, and we're asked for grams of N2O, so 2 N2O for every 1 O2, and then we need the molar mass of that. So nitrogen's 14, so that's 28, 38, 44. Is that right? 28 and 16, yeah. And what do we get? 8.3.
Well, it's 8.5.
Oh, I was like 8.3. That's not a choice. There it is. Yeah, so it comes out to be about 8.3, which is A. That's just mass of A to moles of A, moles of A to moles of B, moles of B to mass of B. An exam like this, a lot of these answers, not a lot of these, but a couple of these answers are probably if you had, switched one of these or something like that. Because the question to me is easy enough if you've studied the material that if you make a mistake of flopping one of those, that is going to be one of the choices sometimes. I don't always do that. If it's just a straightforward, if it's just a more advanced calculation where you're doing multiple figures, but something like this, it's just there's no formula. It's just a dimensional analysis going from mass of one to mass of another. So I need to make sure that you know what you're doing. Questions on this? All right, 3 grams of O2 and 5 grams of N2, which reactant is limited? So we're just going to calculate the product from each of these. And then we'll be able to tell which one's limited, right? And we've already done the first one, right? It's right there. 3 grams of O2. Okay, so we know it's 8.3. We can now do the 5 grams of N2. whoops, times 28, whoops, it's supposed to be 28. 28 grams of 1 mole times 2N2O, and of course the balancing is for every 2N2, and then times, this will be the same, 44 grams per 1 mole, and what do we get there? What is it, 7.9? 7.9 grams. So that tells us, and that's going to be the answer to our next one, 7.9 grams. That tells us that N2 is limiting, and we will get 7.9 grams. Questions? We good? All right. I think there's one more question on this. Is that right? Or 1 through 7, 2 more. With unlimited O2 and 25 grams of N2, what is the theoretical yield of N2O? What do you want to do here? Absolutely nothing. What do we do? Who's talking? Houston, what's up? That's the first step. Tell me what you're doing. Why are you converting it to moles? What do you?
Figure out how many grams of N2O.
Right. So we want to figure out how many grams of N2O produced. That's our theoretical yield. So Houston's right. We're going to take this 25 grams of N2 and convert it to moles, and then we can take that all the way to grams of N2O and compare it. We don't compare it. This is just theoretical yield. The next one is percent yield. So let's do that. 25 grams. We've got unlimited O2 and 25 grams of N2 times 28 grams for 1 mole times moles of N2O. So 2 moles, 2N2O, right? For every 2N2. And then the molar mass of N2O was what? 44, right? Times 44 grams per 1 mole. What do we get there? $39, right? Yeah. Well, it's going to be larger than this. 39 grams you should get. Again, these all start to sound redundant. You're kind of sitting there bored. That's a good thing because that means you at least you get it. It's mass to moles of A, moles of A to moles of B. That's kind of the routine. Got some little changes when you do things like empirical formulas and stuff like that, combustion analysis, but the whole chapter is really based on molar ratios. No matter what you're doing, everything comes down to just getting the molar ratios. Now we want the percent yield. And it's the same question as the previous one. So we know we've got with unlimited O2 and 25 grams N2, what's the percent yield of N2O if 2.6 grams are produced? Well, 2.6 grams goes in the numerator or denominator? Numerator. Divided by the 44 grams, right? Times 100, what do we get? 6.6%. That's it for that one reaction with all those questions. I believe this exam from last year was longer than 25 questions. I'll keep yours for 25 questions because you'll be doing a lot more calculations because some of these are based on the previous questions. You don't have to, you just take that number from the previous one. And so yours will probably stick to 25 questions. Yes. Oh, I'm sorry. 44 is the molar mass. We didn't actually test. Thank you. You gonna say the same thing? 39 grams. Did you divided it by 39, right? Yeah. You just ignored me. Yeah. 39 grams. Thank you. 6.6%. Okay. Anything else? Any other mistakes I made? 8. So this is one with just 2 elements. This is more likely what you'll see on your exam. 2 or 3 at most. A compound has the composition of 43.64% phosphorus, 56.36% oxygen. In fact, if I don't give you oxygen, you can easily calculate it. Sometimes, like we had an example, we weren't given the last percentage, you just subtract it. In this case, you're given both. What is the empirical formula? What are we going to do? Percent to mass, mass to moles, divide by smallest, multiply to. All right. Let's do P first. 43.64 grams times phosphorus 30.9738. That's percent to mass, mass to moles. Someone can do that. And then down here we got oxygen. 56.36 grams times 16 grams in 1 mole. Someone can do that.
I got 1.4.
For the first one, phosphorus?
Yes, 1.408.
Okay.
And then second one is 3.522.
3.5225. Okay. Everybody, someone else confirm those, or at least those are good. Okay. Let's divide by the smallest. We need to answer the second one. If you're not doing these calculations in class, you should be. What do we get? 2.5. And that's nice. We can multiply to a whole pretty easily, right? Times 2. So it's P2O5. C. I think you'll struggle more with chapter 8. I find chapter 8 much harder than chapter 7. I think chapter 7 is kind of routine. Once you've done these, it's kind of like, yeah, we've done this enough. I can do this. Boom, boom, boom. You just, for most students, it's working within that constraints of 85 minutes to get 25 questions done. Chapter 8 has a lot more stuff to it. All right, one more question here. If the compound in question 8 has a molar mass of 284 grams per mole, what is its molecular formula? What do we do here? Right, we got to find the P2O5 weight. So that's going to be, what'd you get? 142. 142. So basically we just took phosphorus, which was 2 times 30.97 roughly. And then 5 times 16. And we get about 142. And that's easy enough because you can see it's 2 times 284. So 284 divided by 142 equals 2. Multiply 2 times each of these up here. P4 O10 E. Questions on the review sheet?